Ever stop to think that something as simple as a soap bubble is actually packed with amazing science? We're diving deep into that today,
Oh, absolutely.
using your source material as a springboard to uncover the surprisingly complex world of these iridescent wonders.
Yeah, it's really fascinating how something we often associate with, childhood joy can unlock some really fundamental scientific principles.
Totally. We've all blown bubbles, but how many of us actually know what's going on at a molecular level?
Right. It all starts with understanding this concept called surface tension.
Okay.
Basically, water molecules are attracted to each other, and this creates a tight, almost elastic-like force on the water's surface.
Okay, so it's like water has like a force field trying to make it as small as possible.
Exactly. It's like those water molecules are in a constant huddle,
Yeah.
making it really difficult for them to stretch out and form those thin films that are needed for bubbles.
Interesting.
And that's where soap comes in.
Ah, soap to the rescue. But how does it break up this water molecule party?
So soap molecules are kind of two-faced. One side is attracted to water, we call this hydrophilic, while the other side wants to avoid it at all costs. This is hydrophobic.
Makes sense.
And it's this unique structure that allows soap to disrupt the tight bonds between water molecules, essentially lowering that surface tension.
That makes sense. So instead of a tight huddle, the water molecules loosen up a bit thanks to the soap.
Precisely. This makes the water more flexible, allowing it to stretch and form those thin films that trap air, creating what we know as bubbles.
Mind blown. So we've got this flexible, soapy film, but what makes bubbles take on that perfectly round shape?
Well, think about it this way. A sphere is the most efficient way to enclose a volume like the air inside a bubble, with the least amount of surface area.
So bubbles are unconsciously efficient with their space. That's so cool.
It all comes down to that surface tension we talked about. The sphere is simply the most energetically favorable shape for those soapy films to exist in.
So the sphere isn't just pretty, it's the most energy-efficient way for those soapy films to exist, surface tension in action. But what about the colors?
Right. It's like they hold the entire rainbow sometimes.
You're absolutely right. Those vibrant colors are more than meets the eye. It all comes down to the fascinating phenomenon of light interference. Light interference is basically a fancy way of saying that light waves, like tiny ripples, are bouncing around inside that thin soap film.
So it's like a funhouse mirror for light.
Exactly. Some of the light bounces off the outer layer of the soap film, while some goes through and bounces off the inner layer. And when these reflected waves meet up again, having traveled slightly different distances, they interfere with each other.
Interfere. Is that like a light battle royale? The most vibrant colors win.
Haha, not quite a battle royal, but I like the analogy. Depending on how these light waves align, they can either amplify each other, creating those bright, vibrant colors, or cancel each other out, leading to darker areas.
So it's like a cosmic dance of light waves happening inside every bubble. That's a great way to put it. And this dance, this interplay of amplification and cancellation happening across the entire soap film with light waves of different lengths is what creates those mesmerizing rainbow patterns.
Wow, that is way more complex than I ever imagined. I always just assumed it was the soap itself creating those colors.
It's easy to think that, isn't it? But that's the beauty of science, revealing the hidden complexities behind seemingly simple things. And here's the thing. These principles we see in bubbles, they're not just a soap opera. This light interference, it's everywhere.
Wait, really? Like where? Give me some examples.
Think about the iridescent feathers of a peacock, or the shimmering colors on the back of a CD. Those are both examples of light interference at work.
Whoa, I never made that connection before.
It's all around us. Even something as simple as a thin layer of oil on water can create those same swirling rainbow patterns.
So we're surrounded by these hidden rainbows all the time. That's mind-blowing.
It is, isn't it? It really makes you appreciate the power and beauty of these scientific principles, even in the most unexpected places.
Absolutely. Okay, so to recap, we've learned that soap breaks down water's surface tension, allowing for those thin films to form, and those films trap air to make a bubble. And thanks to those same principles of surface tension, bubbles naturally form into the most efficient shape, a sphere. And to top it all off, we get this amazing light show thanks to the magic of light interference.
That's a great summary. We've covered a lot of ground today.
We have, and I have to say, I'm looking at bubbles in a whole new light now, pun intended.
Me too.
Right.
It just goes to show you there's always more to learn, even about something as seemingly simple as a soap bubble.
And on that note, maybe it's time we try our hand at making some giant bubbles ourselves. Our source material mentioned a recipe for extra large bubbles. I'm thinking we put that to the test and report back.
I'm game if you are. After all, science is all about experimentation.
Exactly. But before we go full-on bubble scientists, let's wrap up with some key takeaways for our listeners. So to recap, we learned that soap is kind of like a mediator between those water molecules. It reduces their surface tension, allowing them to stretch and form those thin, magical films that make bubbles possible.
Right, and it's those same forces of those invisible laws of physics that dictate a bubble's perfectly spherical shape. The sphere, as we learned, is the most efficient way to enclose a space, making bubbles these tiny marvels of natural engineering.
It's like they have an innate sense of geometry. And then, of course, we have those mesmerizing rainbow colors, which, as it turns out, aren't inherent to the soap itself,
Right.
but a result of this amazing phenomenon called light interference.
Yeah, and it's a great reminder that there's often more to things than meets the eye. Those shimmering colors we see in bubbles and peacock feathers, even in a thin layer of oil on water, are all thanks to this interplay of light waves. It really highlights how these scientific principles are woven into the very fabric of our world.
It's like the universe is putting on a light show for us, and we just need to know where to look.
Exactly. And sometimes all it takes is a simple soap bubble to open our eyes to those wonders.
So the next time you see a bubble, don't just see a fleeting sphere of soapy water.
See the science. See the forces at play, the way it interacts with light. And remember that those same principles are at work all around us.
It's about looking at the everyday with a renewed sense of curiosity and asking ourselves, why?
Because there's always something fascinating to discover, even in the most commonplace things.
Beautifully said. Well, on that note, I think we've successfully popped the lid on the surprisingly complex and beautiful world of bubbles.
We certainly have. It's been a pleasure diving deep with you.
Likewise. And to our listeners, we hope this episode has inspired you to look at the world with a little more wonder. You never know what hidden scientific marvels you might find bubbling just beneath the surface.
Keep those minds curious, and remember, there's always more to explore.
Until next time, happy bubbling.